Okay, cool. So I want to stress a couple things before we press on. So the first thing is again, we're moving very quickly, but importantly, everything that we're doing is just building directly on what we've talked about, right? So we talked about the relational predicates, and we introduced our special relation identity, but it basically works the same. I mean, it's special in some ways in what it expresses and how we write it, but it's just another relation. And once we have relations, we can quantify into some or all of the positions. And that lets us start doing a bunch of things. We can say things like at least, at most, or exactly. And what I want to do for the rest of the time is I want to talk to you first about a particular way of saying exactly that's very handy. And this is the notion of definite descriptions. And then if we have time, I want to talk to you about how FOL sentences work. Kind of wrap up our grammar. Helps if I've clicked on the right thing first. So, remember last week at the very beginning, I told you that, hey, when we think about things in English, there's at least two kinds of singular terms. There's proper names, which are just kind of tags. And then there's what we'll call definite descriptions, that are descriptions that pick out one and only one thing. So a definite description picks out a unique object via specifying a description that exactly one object satisfies. Now in English, we actually have a tool for this. Dutch does as well, but in English, right, we have the. And the we use as the definite. It expresses the idea that there's one. It's the Californian logician that works in Tilburg University, say. Or the person who teaches this class. Contrast this with an indefinite description. A philosopher. A person from California. That could be satisfied by many different people. So definite descriptions are another way for us to pick out individual objects. And it does so via a particular description. So you might wonder, well, cool, how do we kind of capture this notion in our logical machinery? The buildup should be kind of clear, right? But it's going to be using this notion of exact. And the analysis for definite descriptions comes from Bertrand Russell, one of the very few instances where we talk some actual history for funsies. So he said, right, if we think in English, the F is an expression that's used to denote, to pick out, to refer to the one and only thing that is F. So if we say the F, what we're saying is there's at least one thing that's F, and there's at most one thing that's F. That is, the minimum number is 1, and the maximum number is 1, so there is exactly 1. And then if we wanted to say that the F is G, so say the Californian logician who works at Tilburg is teaching this class, we could say there's at least one thing that's a Californian logician who works here, there's at most one thing that's a Californian logician who works here, and that thing is teaching this class. So the F is G tells us there's at least one F, at most one F, and the thing that is F is G. But note again, there's two parts here, right? There's the first one of how to capture the, which tells us at least and at most one. And then there's, once we have the, and we want to ascribe things to it, well, cool, we just add some more conjuncts. So how does this look in FOL? Get this. The F is G is going to be expressed as there's at least one F. So existential X, Fx. And then this is going to be conjoined with there being at most one F. which in this case, because we've already got the existential, we can say, cool, for any y, if y is an f, then it must be identical to our first thing. And then finally, that thing we're talking about is also a g. So you get a sentence that looks like this. It tells us, hey, there's at least one thing, there's at most one thing, oh, and here's something else about it. Yes. So if we only need that if what we want to do is say there's multiple. If we're just talking about one, go nuts, right? Another way to say there's at least one f is to say existential x, existential y, existential z, fx conjunction fy. All of that could be true. Importantly, we need the clause to say they're different if we want to say there's at least two or at least three. The different clause forces us to have multiple things being used. Until we have that clause added, we can always just grab the same thing multiple times. Good, it's a good question. Okay, so again, when we're thinking about definite descriptions, if you hear the f is g, it's going to be this kind of sentence. It's going to be an existential in the front, and then we're going to say at least one f, that's the green, at most one f, and that thing that we're talking about is g. This is another way to say exactly one f is g. Just the same sentence, just re-expressed in English. I mention this because this little bit of kit here is extremely handy. We can do a bunch of different things with it. More importantly, it actually gives us a way, potentially, to express everything we want without ever using any names. If it turns out that every object in the domain can be picked out using a definite description, then names will actually be eliminable. There doesn't need to be two kinds of terms, there only needs to be one, and variables. Big if, though, big if. But it'd be cool if it worked. So, let's do a little practice with our definite descriptions. So we've got a domain of universal, it's everything. We've got little d for Dwayne, little m for Miami. We've got the one place predicate is a wrestler. We've got the one place predicate is a premier sports entertainer. And we have the two place predicate lives in. So, using what we just talked about, how would we say the wrestler? Using this key and what we talked about just a second ago. If we hear the, how many are there? Exactly one. There's exactly one. So we will say there's at least one thing that's a wrestler and at most one thing that's a wrestler. We'll say, right, existential x, wx, there's at least one. And for anything in the domain, if we pull it out and it's a wrestler, we must have grabbed the thing we had at the beginning. Again, what does this tell us? This says there's at least one thing that's a W, and at most one thing that's a W. And this is going to be true if and only if there's exactly one thing that's a W. So far, so good? Okay. So how would we say Dwayne is the wrestler? Well, let's think. We know how to do part of this, right? We just did it. We know how to do the wrestler. It's going to look like this. But now how are we going to say Dwayne is the wrestler? What does the is express here? Hint, think Superman is Clark Kent. What's the is express? Expresses identity. So we can say, in this case, we're going to take this clause, this sentence here, and we're going to conjoin it with an identity claim. That our X is identical to Dwayne. So we'll get this. There's at least one thing that's a wrestler. There's at most one thing that's a wrestler. And that thing X is identical to Dwayne. Note, again, the basic structure here is straightforward. We need a clause to say at least, we need a clause to say at most, and then whatever predication we want to add. If it's an identity, cool. If it's some other property, cool. Go nuts. So in this case, right, we can put it in here with y equals d, but that's not going to give us that there's at most one wrestler. Still haven't been told. Could, in theory, multiple wrestlers. Need more. Okay. So far so good? We doing okay? Let's try our third one. The wrestler lives in Miami. The wrestler lives in Miami. Take a second. We can see the first part here, right? The first part's going to be basically what we have under the very first question. At least one thing that's a wrestler, at most one thing that's a wrestler. And then what do we want to say about it? We want to say that thing lives in Miami. Yeah. Yeah, exactly. It's going to be what we have here. Going to be what we have here, but inside the final bracket, we're going to have conjunction LXM. Tell us that X lives in Miami. Whatever the hell X is, we don't care. It's the one and only thing that's a W. Nice. Nice. Now, note, in every one that we've done so far, we've taken a kind of definite description, and we've then ascribed some property to it. Being identical to Dwayne, living in Miami, whatever you want. Let's take our last one. Our last one's kind of fun. The wrestler is the premier sports entertainer. What are we going to do with this one? Close. So importantly, the difference here, that would be the wrestler is a premier sports entertainer. But note that something funny about what we've got in the English. We've got two thes. We've got two the clauses. So we can't quite do that because that's just going to tell us he's a. I want to say he is the one and only premier sports entertainer. So what are we going to have to do? I like the thought though. Let's take what you said, right? We're going to take what we have up here, and this is how we say the wrestler. How would we say the premier sports entertainer? We're going to need to add a second definite description and kind of squish them together. We're going to have to take two definite descriptions and squish them. So we'll go like this. There's exactly one wrestler X, and there's exactly one sports entertainer Y, and X is Y. Or, to put it in symbols, and note, don't worry, there's going to be a lot of quantifiers, but it's easy to read. There's at least one thing X, and at least one thing Y. X is a wrestler. For anything in the domain, if it's a wrestler, then it's identical to X. So at least one wrestler, at most one wrestler. And there's at least one premier sports entertainer, and at most one premier sports entertainer. And finally, our last little bit, those are the same thing. So what do we have when we do definite descriptions? You gotta give me a clause that says at least one, give me another clause that says at most one, force us to have one and only one thing. And then the rest is just figuring out what the predication's going to be. In this case, we just had to do it twice. We had two thes. And if we hear that definite article, you hear the, it's going to be symbolized like what we have at the very top. The Californian, the classroom, ever. Always going to be done. I think there's a typo here, and really, either this one shouldn't be there. In fact, yeah, if we just delete that one, it's fine. It's an unhelpful typo. So importantly, this is a good question. In this case, we don't need all the brackets because all we have is just a string of conjuncts. Because it's just a string of conjunctions. Because, right, how is this sentence going to be true? Well, it needs every single conjunct. Doesn't matter how we kind of chunk it up here. Because in order to be true, every conjunct needs. Okay. So, the things to stress. Again, what have we learned? We learned how to do it least. We learned how to do it most. We learned how to do exactly two different ways. And we now know if you hear the definite article, then you express it using this exactly one clause. Yes, please. Good. So the nice thing here, we could use different variables for these two, or we can use the same. And the reason why is the scope of these quantifiers. Note, the scope of the universals is indicated by the brackets they're immediately attached to. So in this case, this universal only is attached to this conjunct, and this universal is only attached to that conjunct. So we could use the same if we wanted, or we could have used different ones. Good question. Importantly, if we kicked one of these universals up to the front, if this universal, say, had been written right here, then we could not have used the same twice. We'd need to use different variables, because then it would be a clash. Okay. So, I want to wrap up. Oh, I forgot this is still in here. That's good. It's worth talking about a very silly reason why we have these definite descriptions. And one very silly reason has to do with making sure that we can still have the no gaps, no gluts policy. So we can think about the problem this way. If we take the present king of France is bald, is that true or false? Well, I mean, given that kind of famously there are no more French monarchs, it feels like that ought to be false. Not bald, because he ain't. But similarly, is the present king of France not bald? Well, again, if we go around and look at all the hirsute men in the world, we are not going to find the present king of France amongst them. So it looks like there's good reason to think this is false too. But now we have a problem, because this seems to suggest that 1 and 2 are both false. That's going to lead to either a gap or a glut. Neither is good. But we can get around this by using our definite description machinery. we think about how we would symbolize these. For our first one, the present King of France is bald, using our little symbolization key over here. This is going to tell us there's at least one present King of France, at most one, and that thing is bald. So we get bang. Again, what does this tell us? There's at least one K, at most one K, and that thing is also a B. Then, how would we do the present King of France is not bald? Well, this one's interesting, because if we think about where the not goes, there's a way to make this work. Let's have it like this. There's at least one K, there's at most one K, and that thing, whatever it is not a B. But finally, we can also have a third sentence here. It's not the case that the present King of France is bald. And is this sentence, is number 3 going to get this same symbolization as 2? This 3 is 3 written out in the same way as 2. Got it. It's where the negation goes. The negation here doesn't go at the end. If we look at 3, the negation goes all the way in the front. And here's something really weird, right? 1 and 2 can both be false without conflict. Because 1 and 2 both require that there is something in the domain that's a K. There's at least one. Fail. Does 3 require that there's at least something in the domain that's a K? 3 tells us it's not that there's even at least one thing. So by being very careful about our definite descriptions, we can avoid this potential gappy-glutty problem and keep ourselves working with our assumptions. It's very nice. It's convenient. Okay, so we got 20 minutes left. Let's talk about FOL sentences. Now, I want to say a lot of what I'm going to do here is just kind of making sure that we've got everything lined up, that we've got our ducks in a row. The important things for most of our symbolizations, we've already talked through. So this is really just kind of making sure everything's clean in the kitchen. So the first thing with regards to FOL sentences is what we kind of started FOL with. Our language is composed of 6 types of linguistic items. We have names, variables, predicates, our connectives we inherited from TFL, brackets, and finally, the existential and universal quantifiers. And let's say, just like last time with TFL, we'll define an expression of FOL is any concatenation of these symbols in any order you like. Any list of this crap, right? Go nuts. But importantly, not every expression is meaningful. That is, not every expression is going to say something. Now, the problem with FOL is that it's not as simple as TFL. So remember last time, we basically went straight from expressions to defining a sentence. We're going to have a middleman here. We're going to define the notion of a well-formed formula, or a WOF, sometimes hear it. WFF. Say a formula is any sentence or any expression turned into a sentence by adding a quantifier in front. That's going to be the basic idea. But the run up to it, we'll say a term is any name or variable. That shouldn't be surprising, right? We talked about this right at the beginning. Now, what's an FOL atomic formula? These are hideous. I'm going to read them and then explain them. Well, One version of an atomic formula is if R is an n-place predicate and T1 through Tn are terms, then R T1 through Tn is an atomic formula. And two, if T1 and T2 are terms, then T1 identity sign T2 is an atomic formula. So one basically tells us, hey, if you have a one-place predicate, then predicate with one term, cool, that's an atomic formula. Could be a name or a variable. If you have a two-place predicate, loves, then the relational predicate plus two terms is giving you an atomic formula. Whenever you have a predicate, you need to have as many terms as there are gaps in the predicate. And two is just to say, hey, you can write identity in the middle. So we know how to build atomic formula. It's a predicate with whatever number of terms it needs. Some simple FOL atomic formula, right? We just take a predicate and suppose that it has this many gaps. Cool, go nuts. Now, how do we define sentence? Next move. Do not worry, I'm not going to make you memorize this. That's why it's in red. But let's look and see. What is this defining? What does this box remind everybody of? It should look very familiar because many of the clauses are basically the same. It's very much like the definition of a TFL sentence. Because what it's telling us is like, hey, every atomic formula, thing we defined 2 slides ago, it's going to count as a well-formed formula. If you've already got a formula, then you can slap a negation in front. If you've got 2, then you can put, oh, cool, these ones are all the same. 2 through 6, we know. The important ones are 7 and 8. And 7 and 8 tell us that if you've got a formula featuring a variable, then you can put a quantifier attached to that variable in front. So if you have, for example, to go back a slide, if you have fx, you can turn this atomic formula into a well-formed one by putting either an existential x in front or a universal x in front. Just basically saying some things we talked about before, in that variables always need to be linked up with quantifiers. That's what 7 and 8 say. If you've got a variable there, cool, you can bind it with a quantifier. 9 tells us, don't break the rules. So, what do we get if we follow this? We get some sample FOL formula. Our first one, very simple, it's just got a name. Our second one, we've had this atom, right, LXY, and we've bound the X with a universal. So we used, I think it's clause 8. Here we just left it open, except. Notably though, the one thing that 7 and 8 guarantee, what they force us into doing, is that we can't do stuff like what we have at the bottom. And the reason why we can't do stuff at the bottom is we have clashes of variables. Basically trying to bind the same gaps with multiple quantifiers. We can't do that. That's the only grammatical no-no. Finally, we can say, just like last time, the main logical operator of a formula is the operator that was introduced last. The scope is the subformula for which it is the main logical operator. Those should look very familiar. Those are basically the exact same definitions we had for TFL. So we have atomic formula. They get us almost there. We have formula. They get us almost there. The last thing that's missing, the only thing that's kind of in the way, is that some formula are going to have what we'll call unbound or free variables. These are variables that are not attached to quantifiers. In effect, what the quantifiers do, as we've talked about a couple times now, is they tell us how you can replace the labeled things, right? Either there's at least one thing in the domain that you can plug in, or every damn thing can be plugged in. If you just have a variable that isn't attached to a quantifier, you don't know what to do with it. And just to spoil the next slide, that is going to be the thing that prevents formula from being a sentence. Say that a bound variable is a variable that occurs within the scope of a quantifier, and a free variable is anyone that isn't bound. So, looking down here, right, we can see the y. Note that y here is free. It's not connected to any operation. So this has a free variable. How about the bottom one? What's the free variable down here? Nice. Right? If we look really carefully, the existential here, well, maybe the y. If we look really carefully, what's the scope of this existential? Well, it looks like it's attached to these brackets. What's the scope of this universal? Well, it's attached to these brackets. This one attached to these ones. How about your x right here? It's not attached to anybody. This sentence we can't actually follow. We don't know what function we're supposed to use. So, why do we care about free variables or bound variables? The last little bit here, a sentence of FOL is any formula that contains no bound variable or no free variables. Basically, for every variable, we've got an associated function if we need them. Otherwise, we've just got names. This was long and it's kind of complicated, but again, it's really just to kind of put our ducks in a row. The things that matter, be really practical here, is in order to have an FOL sentence, you need a predicate, and then however many terms that predicate requires. So one place predicate needs at least one term. If the term's a name, cool, you're done. If the term is a variable, that variable needs to be controlled in some sense by one of our quantifiers. If it's not, you don't know what to do with the variable. You don't know how to read or replace it. And that's effectively what this is encoding. A sentence is going to be any kind of structured expression where for every variable we know what function it's supposed to be doing the replacement with, and all the names are just being fitted in the way they're supposed to. This is something we're going to practice a little bit. We'll talk about this definition again in the tutorials. But the things I really want you to know how to do are, again, what we talked about already. At least, most, exactly, the. Using identity. Before we move on, pause. What questions do you have for me so far? We feeling okay? Beautiful. That's what we like to see. Okay. So, congratulations on learning your second formal language, guys. Look at that. In a fucking month and we've already got 2 down. We're masters. I wish Dutch was this damn easy. All right. Now note, what have we done? Right? We have learned the grammar and syntax. What we haven't done yet is learned how to say when FOL sentences are true and false. That's what we're going to do next. Now, I want to stress, right? I've mentioned this before, but please, for this time, please do the reading for next week. It will make my life a whole lot easier because what we're going to talk about is construction of models. And this is kind of difficult. So it's worth going and doing the reading. But thank you guys for coming. Take care. Reminder, I'm not here on Friday, but Michael and Miguel will take care of you. So see you all very soon.